Alright, I hope you have had a chance to graph these, and I'll just go over them very quickly, the way that I would graph this. So first of all, I'm looking at this, and I see that I've got a minus 3 here, and I've got a plus 1 there. So my x minus 3 would create a 0 in the denominator whenever x is equal to 3, and so I get a vertical asymptote right away at x equals 3. And so I'll do that one with yellow, and then I get a horizontal asymptote when y is equal to 1. So with my blue here, I'll just put that asymptote in there. And now looking at the 2 here, I'm looking for two values that multiply out to 2. So let me explain how that works a little bit. If I just look at y is equal to 1 over x, maybe that's the simplest, and we know we get this kind of a pattern. If I change this to our current example and I say, oh, let's make this y is equal to 2 over x, I could rearrange this. If I multiply both sides by x, I could say x times y is equal to 2, and then you can see that my ordered pair of x and y are two numbers that multiply out to 2. So I can think about, okay, I would have it like an x of 2 and a y of 1 would work, and an x of 1 and a y of 2 would work, for example. Okay, so now that's with a very simple y is equal to 2 over x. The only difference between that example and this example over here is that instead of looking at the origin and looking 2 over 1 up, I'm going to look at where the intersection of the asymptotes are. So I'm going to say, okay, what are some ordered pairs that multiply out to 2? So for example, my x could be 2 and my y could be 1, so there would be a point. My x could be 1 and my y could be 2. My x could be a half, in which case my y would be equal to 4. So if I go half to the right, 1, 2, 3, 4 up. So I think that's enough. I get a nice little sketch here. And I put my arrows on. So when you draw this, your asymptotes will not be done in highlighter. You'll actually be doing in dashed lines. So make sure you put them in and put your try to make a nice smooth curve. And I'm going to do the same thing down here in the bottom left hand corner, and I'm going to think, okay, my x could be negative 2 and my y negative 1. It could be negative 1 and 2. It could be a negative a half and 1, 2, 3, 4. Also my x could be negative 1, 2, 3, 4, and my y negative half, and then I'll get this nice sketch right like that. Good to go, and let's take a look at our next one. So very similarly here, first of all, I've got my asymptotes. I've got this, whenever x is equal to negative 1, this will create this asymptote at negative 1. Oh, I want to make this a little smaller so I can fit it in. And then my plus 2, or sorry, minus 2 will create this asymptote over here. And now, what about this negative business here? So another way to think about this is that we could say, oh, hold on, having the negative out front, it's really the same thing as saying, well, what if I had y is equal to negative 1 over x plus 1 minus 2. These two are equivalent, right? It means the same thing. And so now again, we can think, okay, I need two numbers that multiply out to negative 1. And we know that when we have negative 1 over x, that our pattern, instead of being in the quadrants 1 and 3, it's in quadrants 2 and 4. In this example, it's not exactly quadrants, but rather thinking of our asymptotes as sort of like the axes. So I would say upper left and bottom right. So now I wanted ordered pairs that multiply out to 1. So 1 and 1 work, negative 2 and a half, or 4 and a quarter, a half to the left and up 1, 2. And that's kind of nice because I get the intercept where it crosses that axis. And on the other side, here is the intersection of the asymptotes. There's a 1 and a 1, a 2 and a half, a 1, 2, 3, 4 and a quarter maybe, a half and a 2. So you can see how quickly, when you've done these things a few times, how quickly you can make these sketches. Alright, in our next example, it just doesn't look quite right at this point. It doesn't have that same kind of format. So if you remember what we're going to have to do. So I want to look at this numerator and say, how can I set this up so that I can factor out an x minus 2. So x minus 2, what would be nice to have on the top is 3x minus 6, because then I could factor out a nice x minus 2. But I don't have 3x minus 6, I have 3x minus 9, so I have to add another minus 3. So in my next line here, I can say, okay, I've got a 3 x minus 2 all over x minus 2 minus 3 over x minus 2. So I kind of do two steps at once there. I factor out this x minus 2, which is common in my first two terms, and I also I separate the 3 and make it a different fraction. So the x minus 2 will cancel out here, and then I'll rearrange the order, and I'll say minus 3 all over x minus 2 plus 3. And notice again what I did is I put this negative sign here, I put on the top here just to remind myself that this pattern again is going to be one where it's going to be in the top left and the bottom right. So here is this minus 2. We'll say, when will I have a 0 in the denominator? When x is equal to plus 2. So when x is equal to plus 2, that is the asymptote, my vertical asymptote. And then looking at the plus 3, there is a plus 3. So going across right there. And now I'm going to draw my points, and I want things that multiply out to 3. So to not the top left, but the bottom right, sort of my virtual quadrant 4 in a way. So I'm going to say 1, 2, 3, and 1. 1 and 3 multiply together. Kind of tough to figure out exactly where that would be. In fact, that would be the square root of 3, so it would be about 1.7. But I could say a half and 6. 1, 2, 3, 4, 5, 6. And there, that gives me a nice kind of guideline of how to sketch this here. And it's nice because I got this intercept right there. And then looking at the top left, again, I'm going to go 1, 2, 3, and 1. And I'll go 1 and 1, 2, 3. I guess it'd be up there. And my graph is going to be looking like that. Okay, I guess the one point would be, I wonder what my y-intercept would be. So what would happen if I plugged in a 0 for x? So looking at this here, I can say y is equal to, and I can look at my original function, or I could look at my change function. It doesn't really make any difference. If I look at my change function, if I put in a 0, I get negative 3 over negative 2 plus 3, which is equal to 3 halves plus 3. 3 halves is the same thing as 1.5, so I get 4.5. So let's see, if I put in a 0 for x and a 4.5 for y, does that make sense for my sketch? Sure it does. So this would be at about 4.5. So that would be that point right there. Alright, now this last one has put a little bit of a twist in here. They rearranged the order, and they also made the x term to be negative. So I guess the first thing I'd like to do is put this back. So I have minus 2x plus 3 all over x minus 1. Now I'd like to also set this up and say, how could I rearrange this? Minus 2x. Now what would make it work so that x minus 1 could go into there? Well, with a little bit of thought, I'm thinking it would be minus 2x plus 2, because it would go in negative 2 times. It's not exactly what I have here. I have a plus 3, so I have to add a plus 1 all over x minus 1. And let's just see how this works. I'll get y is equal to, if out of these first two terms, I factor out a negative 2, then I will get an x minus 1. Let's just multiply that out just to make sure. Minus 2 times x does give me minus 2x. Minus 2x times minus 1 does give me plus 2. This is over x minus 1 plus 1 over x minus 1. So at the end, I will be getting, this will cancel each other out. So here I'll get 1 over x minus 1 minus 2. So there's the graph I'm going to do. Using the same kind of way I was highlighting it before. I'm going to have a 0 in the denominator whenever x is equal to 1. So I'm going to put x equals 1 is my vertical asymptote. And I will also get a asymptote y is equal to at x equals 2. Sorry, at y equals 2. Get those mixed up. Okay, and now I just have a simple 1. This is just a 1 here. So this is the two pairs of numbers that multiply out to 1. So 1 and 1, 2 and a half, 3 and a third, and so on, half and 2. So here is this curve. And over here, pairs of numbers that multiply out to 1, 1 and 1, a half and 2, 2 and a half, and so on. And so I nicely found my intercepts on the x and the y axis. Okay, so I hope that worked for you. We can probably go on to the next lesson now.